Hi everyone, I am the founder of the Grey Blind Owl. Last week we associated arrays and functions, and this week we will learn to associate matrices with functions. In this tutorial, I will show you how to transfer matrices between functions. I will also explain how we can process this data on functions after the transfer takes place. As the dimension of the data increases, the complexity will also increase. Therefore, as the complexity increases, the number of methods we can use will also increase. I'm going to show you 3 different methods and 2 different formats of one of these methods. We include our library hashtag include stdio.h. I define prototypes of the functions here. We will return to this topic later in the lesson. We have 4 different methods here. Actually, 3 different methods, but these 2 functions are the different formats of one method. Okay, we create our main function, integer main, and the curly brackets. Now, we create a matrix and fill it in matrix fixed 1, matrix fixed 1, 2, and 3. Integer matrix 1, 2, 3. The first row 0, 1, 2, and the second row 3, 4, 5, and semicolon. Now, we send our matrix, its row number and its column number to our first function, so version A. Since the type of our function is integer, the value it will return will also be an integer. Okay? That is why we can use it like this inside the printf function, like that. Like that. Printf, some version A, the person sign D. It's an integer value, so this is an integer value. Okay? This is an integer value. Because our function type is integer. So it returns us an integer value again, and the person sign D represent this integer value. Okay, when sending a matrix to another function, only the name of the matrix is written. Matrix is written. So if we want to send our matrix to our function, we have to use only its name, matrix fixed 1. Okay, matrix fixed 1. Here, its prototype, integer, some matrix version A. Integer pointer pointer. Okay, integer pointer pointer, because our matrix has 2 dimensions. Okay, our matrix has 2 dimensions. So one reference for the columns and one reference for the rows. And I send its row number 2, so I send an integer. Okay, integer, and I send 3 our column number, and I send integer. Okay, we send our matrix and its column number and its row number to our sum matrix version A function, and we will get an integer value, and we print that. Now execute, compile, and run. We are here now. Sum version A is equal to 15 because 0 plus 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. As you can see, sum version A is equal to 15. Now, here, this is our first function and first method. This version is the most common and memorable method. We use double star sign in the definition part because we have 2-dimensional array in matrix. 1 star for columns and 1 star for rows. As I said before, with this usage, you will not be able to use the classical appearance of the matrices. So we cannot use the matrix with square brackets. Okay? Matrix, square brackets, row number, and square brackets the column number. This is not legal. Okay, we cannot use these appearance of the matrices. You have to use the alternative appearance when you apply to use this method. Here, a reference. We used this method before in the 9th or 10th lesson, I guess. This is an alternative usage, a reference, and also integer pointer, again a reference, matrix plus row counter times column number plus column counter. Okay, row counter times column number plus column counter. I will show this in our function. Okay, our function integer sum matrix version A, integer pointer matrix, integer reference matrix, because we have two-dimensional array. Okay, we have two-dimensional array, integer row and integer column. We got these numbers and we got the matrix above here. Okay, and now integer sum is equal to 0, I for a row number and j for the column number. We add the elements with the alternative format of matrices like that. For I is equal to 0, I is less than row and I plus plus. For j is equal to 0, j is less than column and j plus plus. Sum is equal to sum plus reference, the bracket, and again the brackets and integer pointer, matrix plus I times our row counter times our column number, okay, not column counter, not j. We use the column number plus j. So our answer here 15. The sum is equal to 15. Okay, the sum is equal to 15. When the for loops finish, sum is equal to 15 and return sum to our main function. Here, sum matrix version A, matrix fixed 1, 2, 3. This part is equal to 15 now, and the person sign D represents the 15. Okay, sum version A is equal to 15. This was the first method. We use two references, and we use the alternative usage of the matrices. Okay, this is the first method, and this version is the most common and memorable version. Okay, now we are here. We send our matrix, its row number and its column number to our second function, version B format 1. Okay, version B format 1. Since the type of our function is integer, the value it will return will also be an integer. The same with this. Okay, the same with this. Its type integer type, so it returns an integer value. Like that. Sum matrix version B format 1, matrix fixed 1, row number and column number. And this version also returns us an integer value. Okay, and now we are here. This is our second function and second method. This version is used a little compared to the first version. We use the classical appearance of matrices, matrix, the square brackets, and this is empty, and column number with the square brackets. We have to write the column number here. Okay, we do not have to use the row number in this area, but we have to write column number here at the definition part in this method. With this usage, you will be able to use the classical appearance of the matrices, matrix, square brackets, and square brackets. This is legal, okay? We cannot, we do not have to use the alternative usage of matrix, okay? However, unlike arrays in matrices, you can use alternative usage as well as classical usage for this method, okay? We can also use the alternative usage, but generally we do not prefer this usage when we use this method. So we will use matrix with the square brackets, okay? We create 3 integer variables for sum and counters. Integer sum is equal to 0, I, j. Okay, we send our matrix like that, integer, matrix, square brackets, this is empty, and the square brackets, this is our column number, integer row and integer column. Okay, we sent like that, so we can use 2 appearances of our matrices, okay? We can use 2 different appearances of our matrices when we use this method. Okay, for I is equal to 0, I is less than row, and I plus plus. For j is equal to 0, j is less than column, and j plus plus. Sum is equal to sum plus matrix I and j with the square brackets, like that. Okay, we can use this. And we return our sum value to our main function, return sum. And sum is equal to 15 again. And we are here now. Sum matrix version B format 1, matrix fixed 1, 2, and 3. This function returns us 15, and the person sign D represents the 15, okay? As you can see, sum version B format 1, 15. Okay, now format 2. We define a matrix interactive, 50 and 50. Its limit values 50 and 50. We create 2 integers to make them counters, I and j. We create 2 integers to want the user to enter row and column numbers of the matrix, row and column. Okay. Integer matrix interactive 50 and 50, I, j, row, column. Now, we want the user to enter the row and column numbers. Printf, please enter the row and column numbers. Scanf, the person sign D, ampersand row, the person sign D, ampersand column. We are here now. I will enter here 2 and 3. Now, please enter the elements of the matrix. I will enter here 0, 1, 2 for the first row, and 3, 4, 5 for the second row. As you can see, sum version B format 2 is equal to 15, the same with this format 1, okay? The same with the first format. Okay, now we are here. Printf, sum version B format 2, the person sign D, sum matrix version B format 2, matrix interactive, its name, only the name, row and column. Okay, we send our matrix, its row number and its column number to our third function, version B format 2. Okay, we send our all datas to our format 2 function, and now we are here. This is our third function and an alternative format of the second method, okay? Second method, version B. But this is the second format of version B. Okay, all the rules are the same with the first format of this method. Only difference between 2 formats is the column number in the definition part. Here, I write here 50, but I send I create a different matrix. Its row number is equal to 2 and its column number is equal to 3, but I send a matrix with the column number 50. Okay, we create 3 integer variables for sum and counters. Integer sum is equal to 0, I and j. We add the elements with the classical format of matrices, matrix, the square brackets. Okay, the for loops and sum is equal to sum plus matrix I, j and semicolon. Now, we use this method when we want to set a limit value for any user and we do not have any idea about the row and column numbers that are entered by the user. Regardless of what the user has set the column value, the maximum column value is always used to access the elements unless the maximum column value is exceeded. Okay? Here, for example, printf element 1 and 1, the person sign d and /n, the reference, the brackets and into integer pointer, matrix plus 1 times 50, 1 times 50, not column numbers like 3, okay? And plus 1 for the first element. As you can see, the first element, the first row and the first column, 4. Here, the first row and the first column, 4. And here, the first row and the first column, 4. But only one difference. Here, integer, reference, integer pointer, matrix plus 1 times column plus 1. Okay, I use the column number, but here I use the 50, our limit value. Okay, they are legal, but they are 2 different formats of our second method. Okay, we use this method when we want to set a limit value for any user and we do not have any idea about the row and column numbers that are entered by the user. But this one is completely different. Okay, this is certain, but this is not certain. Okay, now we are here now. We create a matrix and fill it in. Matrix fixed 2, 50 and 50 again. Integer matrix fixed 2, 50 and 50 is equal to 0, 1, 2 for the first row and the third 3, 4, 5 for the second row. We send our matrix its original row number and its original column number and the max column number to our fourth function, okay? Version G. C. Printf sum version C, the person sign D, sum matrix version C, matrix fixed 2 and 3 and 50. It's max column number. Okay? It's prototype like that. Integer pointer like the first version, but we send the max column number. Okay, we send the max column number here. So the first version and the second version are different with this way. We send our column number, max column number. Okay. So printf sum version C, the person sign D, sum matrix version C, matrix fixed 2, 3, 50, our max column number and semicolon. Okay, we are here now. This is our fourth function and third method. This method is like the first method, but we have to send maximum column number to this function. We use this method when we want to use the first function and we want to set a limit value for any user. This is why we use this method. We use this method when we want to use the first function and we want to set a limit value for any user. Regardless of what the user has set the column value, the maximum column value is always used to access the elements, unless the maximum column value is exceeded. Okay, integer submatrix version C, integer pointer matrix, and integer row, integer column, and integer max column. Okay, its limit value. We create three integer variables for sum and counters. Integer sum is equal to 0, I, j, and semicolon. We add the elements with the alternative format of matrices, like the first version, version A. Okay, we use the alternative usage of our matrix. Okay, for I is equal to 0, I is less than row, and I plus plus. For j is equal to 0, j is less than column, and j plus plus. Sum is equal to sum plus the alternative usage, but with only difference max column. We use only the column number. We use only the column number in the version A, but version C, we use the max column number here. Okay? Good. We return our sum value to our main function here, return sum. And we are here now. Sum matrix version C, matrix fixed to 2, 3, 50. It's equal to 15. And as you can see, sum version C is equal to 15. We finish our program, return 0. That is it for this week. This week we showed 3 different methods and 2 different formats for associating matrices and functions. I recommend that you consolidate these methods, which are quite complex compared to one-dimensional arrays. For this, it will be in your interest to watch the video again if necessary and to truthfully examine this code that I have shared below. Next week, we are going to do 3 little exercises with arrays and matrices. You can find these exercises in the description part and try to complete them yourself by the week. Thanks for all your effort and patience. See you following lecture. Stay tuned.